Okay, I want to show you a different method to solve problems involving Coulombs law. And I really don't recommend using this method because it's less physical, but you get to understand what this R hat, you're going to see this R hat come up a lot this semester. And you get to see, how where it's used and how useful it is. R hat is a unit vector, and it's just used to denote a direction. It's a vector that has a length of 1, and really it's a way to denote a direction. So, and I wrote this in class. This is one of the ways to write Coulombs law in vector form. This is the way I actually write it in vector form, where R12 is the unit vector that points from the source of the force to the object you're trying to study. We call that the test charge. So in this particular problem, we have these 3 charges in an equilateral triangle, and I want to find the force on this object. Okay, I want to find the force on this object due to these 2. I'm not going to draw a free body diagram or anything. I'm just going to make it very mathematical. All I got to do is figure out this vector and then plug in numbers. So I got to find this vector for between these 2 charges and the unit vector between these 2 charges. So let me draw in the unit vector. Okay, let me just draw in the unit vector. So we want the vector that goes from 1 to 3. This is the source. This is the test charge. Again, for between these 2, this is the source. This is the test charge. Oops. It was like that. So those are the 2. And so I have to write down a mathematical expression for this. Now this angle is 60 degrees. That angle is 60. So I got to write a unit vector that represents somebody going in this direction or somebody going in that direction, for example. Okay, that's really what we're looking at. So I got to write an expression for R31 and an expression for R32. So I got to determine the R's, and then I got to combine the forces in unit vector notation and add the forces in unit vector notation. Once I'm done with that, I have my answer in unit vector notation. And then if I want my expression, if I want to know the magnitude, then I got to use the Pythagorean theorem. And if I want to know an angle, then I got to use the inverse tangent function. So let's go back to the same problem. And really what I have to do first here is to find R31. It's a unit vector. It's really a vector that's pointed in, just imagine this being on a unit circle. And you find the coordinates at 60 degrees on a unit circle. That's really your unit vector. The components of the unit vector are the coordinates on your unit circle, okay, at 60 degrees. That's all they are. Okay, so this vector, its x component and its y component are going to be positive. That's a vector. If you put the tail of this vector at the origin, it would point in the first quadrant. So you're going to have cosine of 60 I hat plus sine of 60 j hat. For R32, if you put the tail of this guy at the origin, you would see that it would be directed in the second quadrant because the x component is negative, the y component is positive. Then all I have to do is plug in all my k's and my q's. So let's look at calculating F31 and F32. So I have 3, 1 is the actual force between 1 and 3. And I'm going to write it as a vector. So it's going to be the magnitude of this vector times this direction vector. So I'm going to write, and again, I'm going to suppress the units because I don't have enough space here. And I'm going to multiply by the 2 charges. This one's positive, and that one's positive. And let me put in this unit vector. And then let's do the bottom one. Not the bottom one, F3 too. Which will be in the bottom here. Okay, so when I do F3 2, then I'm interested in these 2 objects. I'm actually going to put the sign of the charge in this case in my equation. If you distribute that -4 all the way through here, you will see your components of the force will have the same signs as the case when we did method 1. When you add all this together, when you sum these forces, what you'll get again is and compare it to the previous video, the example in the previous video. You'll get the same thing. Okay. I mean, if you compare to the previous video, you'll see both of these are positive. And if you distribute them minus all the way through, you'll see that this one's positive and that was negative, agreeing with what we had in the previous video. Okay. And this is another way to solve the problem. It's more mathematical. It doesn't really give you any physical intuition. So I really request that you don't do the problem this way and do it the other way. It's more physical. And the reason why I'm showing you this is because we have to get used to using the R12. Okay. All right, that's it for this example.